How many rectangles are there in 8 by 8 chessboard? Now, to find how many rectangles are there in 8 by 8 chessboard, we have to first understand how we can make a rectangle. To make a rectangle, we just need 2 horizontal line and 2 vertical line. Now, in this chessboard, we will look how many horizontal line and vertical lines are there. So, in total, there are, on a larger scale, there are 9 total horizontal lines which are colored in red and 9 total vertical lines which are colored in green. Now, to make a rectangle, we just need 2 horizontal line and 2 vertical line. So, from all of this, we will have, from total 9 horizontal line, we are just selecting 2 lines, and from total 9 vertical lines, we are just selecting 2 vertical lines. So, as these 2 lines are compulsorily we have to take to make a rectangles, so we will just take 9 combination 2 ways are there to select horizontal line into 9 combination 2 ways are available to select a vertical line, as both are compulsory. So we have just multiplied it, and so whatever answer you will get, so you will get this 9 combination 2 as 9 factorial divided by 2 factorial into 7 factorial. If we further solve this, we'll get the final answer, that is 1296. Means in total 8 by 8 chessboard, there are 1296 rectangles are available. Next question is that the company has 10 members on its board of directors. In how many ways can they elect a president, a vice president, a secretary, and a treasurer? Now the question is that we have to select all these 4 persons, and it's compulsory that we have to select all of these 4 persons among 10 members of directors. Now as we are having 10 members, so we are just roughly written 10 members over here. These are the 10 members. Now for the first position, that is for the president. Now one president can be selected. As among all of these 10 members, as I'm first selecting president, so it is having possibility that among 10 members I can select any one as a president. So for this president position, I will be having possibilities of 10 members, like I will have choices of 10 members. Now next is that we have to select vice president. Now this is selected along with president. Now after you are selected president, means one member is out from your race, and we have just remained with 9 members. Among 10 members, one member is already selected as a president. We don't know which member, but that is selected. So we will be left with only 9 members. So from 9 members, you can select anyone as a vice president. Now this position is also filled. 2 members at this place are already consumed. Their position is already considered. Now we will be left with only 8 members. For selection of secretary, among 8 members, we can select anyone. So for secretary position, we are having total 8 choices. And the last is we have to select a treasurer. Next, for treasurer, 3 members are already selected, that is a secretary, a vice president, and a president among 10 members. So we are just remaining with the 7 members. Among 7 members, you can select anyone as a treasurer. Why we have multiplied this? Because it is given that you have to select in how many ways you can select president, vice president, secretary, and treasurer. This here there is a and symbol is present, or and word is present. That's why we have multiplied it. And so these many are your possible ways to select all of these members. So there will be total possible ways will be 10 into 9 into 8 into 7. So there will be 5040 ways you can select a president, a vice president, a secretary, and a treasurer in a board of directors with 10 members. Next question is that, now this is one of the most example question where we are just covering combination with repetition. Question is that you walk into a candy store and have enough money for 6 pieces of candy. The store has chocolate, gummies, and horrible Chinese candy. Now these 3 are the categories of my candy. That categories of chocolate, gummy, and horrible candy. How many different selections can you make? Given is that we are just having money for 6 pieces of candy, and we are having categories of candy as chocolate, gummies, and horribles. I mean in total there are 3 categories of chocolate are there, and from 3 categories of chocolate we have to select 6 pieces of candy. So this is the question given that we just have to select 6 pieces of candy and 3 categories of candy is available. Now when we are solving combination with repetition, we can have different kinds of formula. So we are having formula. First formula is that how many categories are available plus how many things you have to select minus 1 combination with how many things you have to select. Next formula based on the same thing is that how many categories you are having plus how many pieces you have to select or how many things you have to choose minus 1 combination with how many categories you are having minus 1. These are just the formula, and the last is slots combination with dividers. Let's understand this formula with this solution to this problem. Suppose you are having 6 candies, you have to select 6 candy pieces from this 3 categories of candies. So one possibility is that I am just selecting 4 chocolate candy and then 2 gummy candies. Now to make a separation among all of these 3 categories, I will need to keep my divider over here and here. Next thing is that I am selecting 2 chocolate candy, 2 gummy candy and 2 horrible candy. Now I have to separate out each of this category of chocolate with each other. So I will keep one divider over here, one over here. So next is that possibility is this, and last possibility is that I have selected all the horrible candies. I have not selected any other type of candy. So again you have to make a separation of all types, all different kinds of candy with each other. As there is no chocolate candy, just we will keep a divider which is kept on the blank side. Again for gummy candy, I have just kept one divider, which is I am assuming that if I will be having any gummy candies, I will need to keep a divider over here. And the horrible candy, though there are not any single candy is available for chocolate and gummy candy, but still we have kept a divider for their consideration. Their value is of their count is none. So in total if we look at this, so we will see that for all of these possibilities, so we are having 6 candies to select and 2 dividers are there. So if we'll just calculate how many slots are there, so these are 1 2 3 4 5 6 7 8 8 slots are there, among which 2 are dividers and 6 places of candy. So there are total 8 slots, and among 8 slots 2 dividers I have selected, 2 places where I am dividing. So from the third formula in the previous slides, we can calculate the count of different selection for this particular question by using total slots combination with dividers. There are total 8 slots combination with 2 dividers. If we'll solve this, we will get the answer, that is 28. Next is that when we are having your formula, that is when you are having your formula of n plus r minus 1 combination r, or we can also read this as n plus r minus 1 combination with n minus r. Now in this formula, my n is categories, how many categories of candy you are having, r is how many things you have to select. So in this case we will use this formula just like the formula which is present on the previous slide. Here I am just considering n categories as n, thing as r's, how many things you have to select. So in that case our formula will become this, n plus r minus 1 combination r. So if we'll just put the values of all of this, I am having 3 categories of chocolate plus 6 candies I have to select, minus 1 combination with how many things you have to select, that is 6. So I will get the answer, that is 28. If I will go with another formula, that is how many categories you are having, n is 3 plus how many things you have to select, that is 6, minus 1 combination with how many categories you are having, that is 3 minus 1. So you will get the answer, that is 8C2, 8 combination 2. If you will solve this, we will get the answer, that is 28. Now in some of the books there is also written that formula is n plus r minus 1 combination r minus 1, or n plus r minus 1 combination with n. The formula is correct, but the thing is that they have just instead of considering n as categories, they have considered n as how many things we have to select. So if you're just making change in the labeling, this formula will be the same which is on this slide. So like my formula will be the same, but the labeling will be different. So in this case, if I'm considering n as things to select and r as categories, my formula will become n plus r minus 1 combination r minus 1. Just we have changed the name, just we have changed the labels of these two things. Instead of considering n as category, now I am considering r as category. Now in this previous formula, instead of considering r as things to select, I have considered n as things to select. So just here we just have to replace wherever we are having n with r, and wherever we are having in this formula r, we have to make a change that as n. So if we'll do this, we'll get that equation, that is n plus r minus 1 combination r minus 1. So I'll just consider to change this formula. So if we'll solve this, we'll get the answer, that is 28. So if you'll go by any of these ways, you will you can get the same answer, that is for 28 for this question. Next is that you have to find 8th term. Next question is that you have to find 8th term in the expansion of x plus y to the power 13. Now for calculating any term whose expansion is something, so for that particular thing we always go for selection of coefficient of your binomial terms. So first of all, we will understand what is a binomial theorem. Now binomial theorem is of kind of this: a plus b raised to n. Now this can be expanded as summation of n combination r, a to the power n minus r, b to the power r, where your value of r is starting from 0 to n. Now if we'll just keep all of these values for r as 0, then 1, 2, 3 and n, we'll get the formula, which is this. Now in this question we have to find 8th term in the expansion of x plus y to the power 13. Now from the question we are understanding that we have to find 8th term, okay, and x plus y to the power 13. So here 13 is my value of n. 13, a is my x, b is my y, and we have to find 8th term. Our first term always start with value of r is 0, second term with 1, third term with 2. So if we'll go on, we will get that our nth term will be n minus 1th value of r. So for finding 8th term, we have to find the value of coefficient whose value of r is 7. So the 8th term will be our NC7, a to the power n minus 7, b to the power 7. So we are just having this. Here we just have to make a change. Instead of a, we have to keep as x. Instead of b, we have to consider it as y. N is 13 and r is 7. So if we'll just make a change over all of this position, we will get that is 13c7, x to the power 13 minus 7, y to the power 7. If we will solve this, we will get the answer, that is 1716, x to the power 6, y to the power 7. So this is our 8th term in the expansion of this particular equation. Next question is that how many integer solutions are available to this particular equation, that is a plus b plus c plus d is equal to 15. A is greater than equal to minus 3, b is greater than equal to 0, c is greater than equal to minus 2, d is greater than equal to minus 2. Now for any kind of equation where we are using the formula of n plus r minus 1 cr. Now for understanding this formula, we have to find what is the value of n and what is the value of r. So whatever you are having, how many variables you are having on the left hand side in the addition, that are the values of your n, that are the categories. So value of n is 4. The value which is present on the RHS side of your equation, that is the value of r. And our formula is n plus r minus 1 cr. If your all the variables or all the categories are starting from 0, then we don't have to consider any change in value of r. We will use all of this value for the calculation of formula. But instead of that, your some of the variables are starting from any other values. So what we have to do, these are making some restriction on categories. We are having some restriction on categories. So we just have to try to make our variables start with 0. So to convert this is a is greater than equal to 0. What thing I have to do? I have to perform addition of 3. Minus 3 plus 3 will become 0. So whatever thing I am doing on value of a, the same operation I have to perform on my value of R. So as I have added 3 over here, I will simultaneously add 3 in the value of R. Next, B is balanced. Okay. Now we will see C is greater than equal to minus 2. I need to make change over here. I should consider that in which way I will get C is greater than equal to 0. So if I will just add plus 2 in this, I will get that C is greater than equal to 0. Plus 2 minus 2 will become 0. So as I have added plus 2, so I will simultaneously add plus 2 in R. The same with D, I will simultaneously add 2 which I have added for making D as a 0 in R. So our equation of R will become 15 plus 3 plus 2 plus 2. So if we will calculate this, our value of R is 22. So what is new value? Whatever your new value of R you are having, you just have to consider that value, not the old value. So I'm just considering this value for solving this equation, like how many integer solution are available for this equation. Standard formula is n plus r minus 1 CR. You just have to keep all of these values. The n is 4, r is 22, new value of r is 22. So just keep all of this value, you will get the answer, that is 25 combination 22, which is equal to 2300. Next question is based on the Pascal triangle. Now in the Pascal triangle, first row always start with only one value, that is of 1. In the next row, in Pascal triangle, at the left hand side and the RHS side, at the extreme corners of your triangle, we keep 1. So we just have to keep 1. And the middle values are calculated with respect to what are the previous values of your that particular column. So based on that, we calculate the value of our cell, new rows cell. So on this I will keep 1. Now 1 1. Now on the third row I will have 3 element. So I will keep 1 over here on the extreme corners and 1 over here. Now this place can be calculated as sum of two previous terms on the previous row. So these are 2, 1 plus 1 is 2. Now fourth row will have 4 element, 1, these 2 places and 1. Now this place element can be calculated as previous row ka respective elements ka sum, that is 1 plus 2. Now this place can be calculated as 2 plus 1, that is 3. In the same way, we will go for calculation of remaining rows. Now based on this Pascal triangle, we are having questions like how you will get the answer, how you will expand this equation, 1 plus x or 1 minus x to the power n. So if your equation is of this kind, so from this Pascal triangle we can easily get the answer. So if I want to calculate what is 1 plus x to the power 3, now here positive power 3. So if you are having plus power 3, and in that case you have to go from top to bottom, and you just have to look for the value of row which is having r as equal to 3. Now for calculation of positive value power, we always consider first horizontal line as row for your r equal to 0. Next horizontal row is value for r equal to 1. Third horizontal row will be having value of r equal to 2. In the same way, nth horizontal row will have value of r equal to n minus 1. So for calculation of 1 plus x to the power 3, we have to look the fourth row from the top, that is this, and whatever you are having all of these elements from left to right, all of these are coefficient of your x to the power I. So x to the power I is where I is starting from 0. So this is coefficient of x to the power 0. This is coefficient of x to the power 1. This is coefficient of x square, x cube. So you just have to perform addition of all of this. You will get the equation, that is 1 x to the power 0 is 1. So it will be 1 plus 3x square plus x cube. This is the value for 1 plus x to the power 3. If I am having value of 1 minus x to the power of 3, positive power, so in that case alternatively you will have minus sign on the places of x whose power is odd. Next is I have to solve 1 minus x to the power minus 3 in the negative power with negative sign inside your brackets. Your equation will become, you have to search for diagonal rows diagonally you have to search for all the values from top to bottom, from rightmost corner to leftmost corner. So in this case, note here, in this case your first row is always considered as whatever first diagonal row you are having, that value is your value of r equal to 1. Now as my negative power is 3, so I have to check what is the diagonal value for my r equal to 3. So which is my third diagonal row, that is first, second and third. So that will be my answer to this particular equation. And all of the member from top to bottom are your coefficient of x to the power I, where I is starting from 0. So this is coefficient of x to the power 0. This is coefficient of x to the power 1. This is coefficient of x to the power 2. This is coefficient of x to the power 3, and so on. So we just have to perform addition of all of this, we'll get the answer. So this will become 1 plus 3x plus 6x square plus 10x cube plus so on. Now if I am having question that is 1 plus x to the power minus 3, in this case, in the negative power where you are performing addition inside inside of your brackets, so in that case you will be having negative sign for your all the coefficient of your x where x is odd. So I will be having equation as 1 minus 3x plus 6x square minus 10x cube and so on. So you just have to make a note that in positive power we will have limited amount of terms, and in negative power of your this term, so you will be having infinite amount of values or coefficient or terms. And summary for permutation and combination. Permutation without repetition will have formula of NPR. If you are performing the same thing for your arts, for your words where you are having, you just have to find how many permutation are available for given word. So the formula is total characters of that word divided by, for each particular character from A to Z, just take how many count of that character is present, the count, factorial of that count, multiplication of how many other characters are available. Like suppose I am having A in my word, so how many A's are available, that count, factorial of that, multiply by if I am having Z in my word, so how many Z characters are available in my word, that count, factorial, into so on. So that many characters you are having, perform all of this multiplication for all of the characters, so your permutation will be this. If you are having permutation, you just have to arrange some things where order matters, and with repetition, so in that case our formula becomes n to the power r, where n is set of elements and r is how many things you have to take at a time. So for all of this, n is and r is this thing. Combination is just the selection where order doesn't matter. You're just taking out the element and you're not arranging that element. So in that case, without repetition, our formula is NCR, that is n factorial divided by r factorial into n minus r factorial. And if you're making, like if you're performing combination with repetition, then your formula will become n plus r minus 1 CR, where n is categories and r is how many things you have to select, which is equal to n plus r minus 1 combination n minus 1. And again in that also you have to ensure that from each different categories at least one element should be there. So your formula will be r minus 1 combination r minus n. Now here value of r is always greater than n, so just use this formulas.